All right, let's go ahead and get started. My name is Sean Charon. I'm a software engineer with Wolfram Research, and I'm on the Sound and Vision team. For the past 5 years or so, I have been working on import-export in a number of different capacities. I've worked on the functions import and export and the internal mechanics of how those things work at a framework level. I've also worked on a number of formats like MBOX and really popular ones such as CSV and Excel. So as you've already seen in the abstract, I do this talk pretty much every year. And this year, we're going to go over some brand new formats and additions to important formats that I'm sure that you've already been using. So specifically, we're going to talk about some statistics related formats that we introduced import for last year. Now we have a corresponding export for those things. We're also going to talk about some updates in metadata and image. We'll talk about new features in the PDF format and introduce new system functions that let you interact with some of the metadata behind the functions import and export. Let's dive right in with stat export. And before we begin, I want to say that please feel free to message in the chat or raise your hand on Zoom. If you have any questions, I'd be happy to stop and answer them right away. Okay, so like I mentioned, about a year ago, we introduced these formats in import, and now we have corresponding exporters for those things. So these are statistics formats that are typically used to store data sets that are tabular. This is a format that supports missing data and a variety of data types, standard machine precision numbers and whatnot. So just for a simple example, let's take a couple of lists of data and export it to DTA. If you get this thing as a data set, you'll notice that there's these inserted column names. With these stats formats, you do need to have a column name, so we'll automatically insert those for you if you haven't provided them. In terms of data structures, you can export various types that are built in from language. Basically, any kind of tabular data structure you can think of should work out of the box. So here's a data set that actually has some column information built into it. You'll notice that those columns are picked up when we export the file. We can also take associations of named columns. And this is kind of an exciting thing, actually. We're starting to think of data rather than just being lists of lists, but also something where you can give it a name and provide a column of data that can then be efficiently packed. So if you look at this, we exported a data set that has two columns named A and B, and they have a few data points in there. You'll also notice that we inferred the data type from the data itself. And moving on to data, you see that the data was exported in the columnar fashion that we expected. We also support various types of missing data from Wolfram Language. And these things are actually built-in types in the stat formats. So if you look at this thing, this is still a column of integer values, as we can see in column descriptions, but there is still a missing point in the data set. And like I mentioned, most tabular data structures are already supported automatically. So if you look at this time series here, you can take a time series object directly and export it to any stat format. Things like matrix form also work. We spent a good amount of time on really making the exporter smart and understanding what you want to do ahead of time without having to spend a lot of effort controlling the data types if you don't want to. So if you look at this, the first column has a real value here and integer there. The entire column becomes reals because we were smart enough to infer the most appropriate type for the column that you were given. And if we look at some of the more advanced options in stat formats, you can control all of these things yourselves. You'll see that there's a column descriptions option that gets passed to the function export. In import, we also have an element called column descriptions. You can pass one of these specifications directly to that option and embed the names, descriptions, and types of your columns using this option. And if you look at the data set, you can see that even though we provided it 2D data that wasn't named, we were able to give it a name, some description, and some type. If you look at the column descriptions here, you'll see that these things all ended up being real 64, even though we had input originally only integer data. Moving on to the next example, there's different ways that you can specify these column descriptions. If you don't want to give it this big association, you want to just give it some names, it's going to understand that a list of strings is just the names of your columns. And if we export, oops, not this example, with an association, you can give it the names of the column that were inferred from the data sets. So you can interact with this thing by giving it positions. You can just give it strings. You can give it these association structures that you get back from import, or you can refer to the columns by name and change them directly that way. Or an integer index. See here that we replaced the third column, and also we replaced the column named call1. The next brand new format is NetCDF in export. Oh, sorry, no, this one, there's another format that we have new in export, but for NetCDF, what we have is a brand new importer that got a complete overhaul. It has a new backend and extended support. So that means that we have new features, but also we support a new version of this format. NetCDF version 4, which is rather popular these days, is now supported in addition to v3. And in terms of features, let's just dive right in. Now there's a convenient way to ask for a specific data set without having to pass some complicated expression, so you can get straight to the data that you need. And like I mentioned, there's a completely new structure. If you take a look at the dimensions and metadata in 12.3, it can be hard to associate these random pieces of data with where they are in the file or a particular data set. Now, in version 13, you have an association structure that gives you the name of each data set in addition to its dimensions. If you ask for metadata, again, this structure is now an association. With the numerical data, we have numeric arrays for increased performance. These things can be extremely efficiently packed, and these functions are extremely fast. If we move on to some more structure that we added to the NetCDF format, we have NetCDF is a structured data format. It's similar to HDF5 or maybe MAT if you've heard of those. With NetCDF, it also has a bit more structure that is required by the format. Every single dimension in the file structure needs to have its own name. So we expose those things as first-class citizens. If you ask for dimension names, it gives you the name of the dimensions per each data set. And you can look at those named dimensions with the named dimensions element. And you can see that we have lat and lon here as dimension objects. Data format gives you a description of the type of underlying data that you can expect from the file. Here's a more complicated file. You'll notice that we have a data set that has different chunks of data built into it. This is a specific type of NetCDF file where it has a compound data format. So you'll see that this data format thing compared to above is quite a bit more complicated, because with this one file, we just have a set of real 32 values. These could be real 32 values, they could be integers, they could be some kind of ragged array, or they can be a compound data structure. So let's format this a little bit nicer, and you can see out here at the top level for our data sets, we have this compound data structure, and inside that structure, it has its own name, its own class, and its own format. Since we have updated so much in the NetCDF format, in case you have some code that relies on pre-existing behavior, we definitely encourage you to use the new stuff, because there's a lot of really good improvements, but legacy is still available in any format or in any element just by appending the name legacy to the code that you already had. As you can see, you might not have as good of results with data legacy, for example, if you're working with a V4 file that wasn't supported before. So this is a really exciting one for me. Like I mentioned, I've been here and working on particularly import-export for 5 years, and this is something that was always really exciting to Stephen as well. He's always been really interested in analyzing his email, and we have built some of the most advanced features out of any programming language in the world to interact with not just the emails themselves, but the entire thread of your network. So just to start, we're going to grab a file from this data set online. And we have an MBOX file from Apache that has all kinds of messages in there. We can now import this thing as a graph. The way this graph works is every single node here is associated with their message ID, which means that we can interact with this graph and manipulate our data just by getting certain pieces of data with message ID first. So these labels are very simple. All we're going to do is grab every single message ID in the file and have that point to a tooltip that gives you, for example, the body preview of the message. And body preview is great because it only takes a look at the new content in the file, and then it gives you a snippet of that that is digestible so that you can get a sense of what the email contained. So let's go ahead and take this graph and add the vertex labels from message ID going to that body preview. And now you can hover over any of these nodes and get a sense of what content was listed in that email. MBOX has a very large list of elements, and I can even just pull that list up right here. You can take any of these various pieces of information that you want to analyze and stick that in this same example right up here. Anytime, instead of body preview, any of these elements, whether it's the from address, the full contents of the message, just the quoted contents, some kind of header information, if you want to see where these messages are coming from, you can stick that right in there and analyze the entire network of your graph. There's all kinds of different elements that we've added to give you a sense of the contents in these threads. So the thread count is going to be the total number of threads that are connected together in that graph there. Then there's various elements such as the email count that go by each graph in that network. So these things are ordered by the date the thread started. So the starting date of the first email that spawned the graph, which is pretty apparent here if you look at these thread time intervals. You'll notice that this interval is instantaneous because there's only one email in the thread that never got a response, which is, a pretty useful piece of information if you're looking at an entire mailbox of emails that you sent out, and you want to analyze which ones aren't getting responses. That's the kind of programming that you're able to do in Wolfram language. And we can look at the duration of these things, which could give you an easy sense of, and we can round these values to give you a pretty quick sense. Do your messages in your mailbox span weeks? Do they span just a day? How long are these threads? And the message ID thread list gives you another way to map your data to each of those individual nodes. And another threaded view of the from senders of each of these messages. So we could also grab some labels of, say, the body here and put it on the message elements. And there's one other pretty cool thing that gives you a sense of the interworking connections between all of the emails. So if we look at the original graph of this one here, we see that this one's quite a bit smaller than the original email that we were looking at. We just have 3 sets of messages in the thread. Now, these have a relationship with the message they reply directly to. But if you look in at the headers of the messages, there's also a references header that points to every single message along the chain so that you can get an idea of the entire network of one email and every single other email that it corresponded with. And that looks like this. And we did the work of processing the header elements manually, and these connections actually exist in the metadata of your emails. But there's another way that you can think of it. If we just take the original thread graph and take the transitive closure graph of that thing, we end up with basically the same thing. This isn't always the case because, of course, email servers can lie. But most of the time, if the email servers have done their job, the transitive closure graph of a thread graph is the equivalent of this reference message ID graph. So those were all framework-specific updates and big new features. Let's discuss something a little bit different before we go over our final updates. There's this tutorial that you may have seen about importing and exporting, and a few years ago, I gave a talk about some of the various ways that you can hook up your own formats to the system. And while we have built the most massive programming language in the world, the most massive computational language, with everything pretty much built in, we also want it to be a flexible and extensible language. So we've given tools to register specific formats that hook into our network of import and export. Often when you're doing this kind of thing, you need to know certain things about that file format's properties. And the kinds of things that we're talking about here, and this first syntax here, bracket, bracket, will just give you the list of all file format properties we have in our system if you want to analyze everything. And this thing is updated in real time. So when you modify the system, these changes take effect and it's always going to query the new values. So let's take a look just at one of these particular things. Let's ask for just the file format properties of CSV. You can see that, oh, I suppose because I've ran something, the default element is dataset, but were I to quit the kernel, you'll see that this thing changes a bit. Great. Now, the default element for CSV, if you go look at the documentation, is data. That's something that wasn't obvious to get from the start. This is a piece of information that was in the system and in the documentation, but you weren't able to know what the name of that thing is. Now you can look that up. There's also some baked in information in the system that says when I call import of file.csv, it gets interpreted that that's a CSV file and that's the format you should use. Well, at least it gives it a guess. And now you can have access to the direct information the system uses internally to make that decision. You can get the import elements, which you already were able to do with the elements element. And then there's also MIME types. So the MIME types are information that you get in some kind of HTTP response or in an email that says this content, this payload is of a particular type and gives your system a hint so that it can interpret the content correctly. So if I call import string on some chunk of data as CSV, you'll see that it imported the data element. You can actually set these things now too. So with set file format properties of CSV, we can change that default import element to dataset. Now every import for the rest of your session knows that you're supposed to use the dataset element. So you can ask for the list of properties that you might get and also query specific things from file format properties. So there's the import elements, which it gives you directly, or if you ask for more than one thing, it gives you that association. So this gives you a mapping from every format to the metadata that our system uses to interpret the contents. If we look at the other direction, you might want to know if you were to ask the system, you know, I have some star.264 file or foo.cdf. What does the system think that format might be? You'll see that you can even get multiple results from this. There could be some kind of overlap that uses the same extension. This list tells you that the most likely thing that it is probably a CDF just given its name. This is completely a string operation. It gives the system a hint about what kind of data it should use. But file format is the function that tells you, if I look at this file and I look at its contents and it has this extension, and, maybe for certain formats like binary formats, the audio formats, it checks the first few bytes to see if it actually looks like an MP3 file first. So it's not just the string itself. This function gives you just the string itself. And we can do the same thing in the other direction with MIME types. MIME type to format list also takes a pattern so that you can take a look at all of the video related MIME types that we have in our system. Okay, so we have just some updates to a couple more formats that we thought were pretty interesting. So to start with, if we get this article from the internet, and Stephen mentioned this in the keynote, we were able to get page images already in the last version, and these are totally faithful renders of the data. And if you call head on that, you're going to get an image. Well, now we have a much stronger representation of this content in terms of a graphics object. So these things are all actually, curves. These are all graphics elements that you can do all kinds of weird things with. But the more important thing is that when you have a graphics object, well, two things. One, it's a vector graphics, so this thing is going to scale. And two, it's a computable object. Let's move on to these image formats. So in WebP, we now support the import and the export of animated WebPs. And that's a little jarring there, but as you can see, we can just take some image data and now it can be round tripped in WebP. We optimize the animations by adjusting the duplications so that you get a smooth result. We also support more metadata in the WebP format. So EXIF and XMP, like we used to support in JPEG and other formats, is now supported in WebP. And for example, we can take a look at some of the EXIF data in this particular WebP file. Onto Hive. I'm on a Mac, so I can show you this. We now support export of Hive on a Mac. That is also very bright. And the last format that I want to talk about is OpenEXR, which I think is pretty cool. I didn't have the pleasure of working on this myself, but I learned a little bit more about the format recently. And OpenEXR is a really complicated format. It's used in image processing and rendering when you need to have a lot of different chunks of data that give you various aspects about that data. So let me just give you some examples, right? Let's say that you have a bunch of pictures and you want to be able to say, from this view, this is what you would be seeing. And this is just a flat list of things. So that's called the scanline method in OpenEXR. And so the scanline thing has a bunch of complicated metadata, but also in particular, it takes these images and can combine them into different views. Then we have MIPMAP, which is where we get even cooler. This is very similar to image pyramid, where you have the same image given at a bunch of different resolutions. So let's take this, this file, which has all these images at different resolutions in the first data set called default, and let's take a look at its channel data. So what a MIPMAP does is it takes all of these images and it halves both of the dimensions over and over again until you get to 1, 1. What would you do with all these images? Well, let's say you are creating a 3D environment and you have a camera and you want to render different objects at different distances from your camera. Well, it would be a waste of data to use a lot of pixel values at something that's very far away, because you wouldn't even be able to see all of those details from that distance. And this is called level of detail. So for something that's farther away, you would use one of these images that has less resolution. One level is the exact same as MIPMAP, but it only gives you one image. RipMap is also similar to MIPMAP, but what it does is give you even more data along every single dimension of the image. So you'll see that now we're not having both dimensions, but we're just having one dimension until it reaches 0, then the other dimension until it reaches 1, and then you have 1, 1 in the very end. So OpenEXR just gave you the ability to represent different objects from different distances with different resolutions. But that's not the only thing this format does. It also gives you another image mode called deep. And deep images are interesting because they have structure of the depth of a particular object. So if you were to maybe say take data from a sonogram or something, you can put these things on top of each other and get a sense of the depth of an object. So it gives you multiple resolutions for things, it gives you depth and all kinds of metadata that are associated with these types of operations that you'd want to do. Export is smart. Export is going to, even if you're asking for a MIPMAP, it knows that if you give it one image, that it needs to generate the MIPMAP for you and pack that data into the file. So even though we provided just one random image, this file here is already abstracted for you. And the same is true for RipMap. The deep format is also fairly complicated. I mean, working with OpenEXR, you really need to understand a bit about the internals of the format itself. So if you're familiar with OpenEXR, you know that deep requires at least an A and Z channel. We're going to put both of those A and Z channels there for you if they're not present in your data. And that data doesn't need to be generated. If I take this import, which with all of this channel image, this information, you can export all of this data manually. You can give it every layer of the MIPMAP if you want, or it can be automatically generated. So I can take this association structure and export it directly to an EXR file with no additional options. And if we look at the channel image list, we get pretty much the same data back. We get the exact same data back. And if we look at its summary, it was smart enough to determine that this was in fact a MIPMAP. All right. Looks like I had a bit more than I thought to talk about. There's 2 more minutes left if there are any questions. I'll take a quick look at the chat.
So it looks like the first question was from Glenn. It says, what is the best way to interact with SQL Server? Do you have that question in front of you, Sean?
I do not. To interact with SQL Server. That is a great question for Carlo Barbieri, who is somewhere at this conference. I'm not an expert on the SQL stuff, sorry. I can't give you any info there.
Is there a good way that you can be reached for further questions, or you can have any office hours or further availability during the conference?
I don't have any office hours necessarily scheduled, but if anybody wants to chat with me, feel free to send me an email. That's scharon@wolfram.com. You can ping me on Pathable. I'm active there. I'd be happy to set up any kind of meeting or chat with you on Rocket Chat. I'm also on the WTC Rocket Chat channel. So if you have more questions, you can find me pretty much anywhere.
Perfect. All right. Well, thanks so much for your help and your time, Sean. And hopefully everybody can reach out to him when necessary and you can further inform them.
All right. Thanks all for coming.